Architeuthis.
Welcome to Machine Learning Mondays. I'm Guy Cope with Architeuthis, and this is the series where I try to knock the edges off buzzwords and make machine learning accessible to all y'all. For today's topic,
Unsupervised learning.
Data, the trendy frontier. This is a voyage into unsupervised learning. Our 15-ish minute mission: explore underlying data structures, seek out similarities and connections, to boldly cluster data without anyone's labels. For those who watched my last video, you've probably already guessed that unsupervised models are the opposite of supervised models. Where supervised models require a lot of human intervention to work, creating the features that drive the model and the labels to train it, unsupervised models require less intervention and no labels at all. While a team of experts, both data experts and subject matter experts, still choose the data and select the type of unsupervised model based on a purpose, what happens after that is very different. In essence, humans will tell the baby model where to play and what toys it can have, but humans don't tell the model how to play or what the rules are. That's not to say that humans have no say on what the model does. Humans do have a say on a few things before and after the model begins learning, through things known as hyperparameters and parameters. A hyperparameter is set before the model begins its unsupervised learning. It's a very high-level concept. We're not talking about things like fraud or things like amount of money spent over time. The hyperparameter doesn't tell the model what to look at or how to make connections. Instead, the hyperparameter is still higher level than that. For instance, a common hyperparameter would tell the model how fast it should learn. Should it put more emphasis on more recent data? Or maybe it needs to emphasize a longer period of data. Or how complex it should be, such as the number of branches in a tree, or the size of a cluster that it's going to find. Hyperparameters are just estimates though, and they're determined by testing the model. They're not hard and fast rules like product features, and they don't change or move around like product features do. So once the model goes into production, hyperparameters are actually dropped, and the model begins making connections and clusters on its own. Humans can also add parameters to help determine the output, but the model will also determine some parameters itself. After the model has made connections, whether it's looking for large complex clusters or small distant outliers, parameters will help the model determine what's relevant to the human. Essentially, let's say you have a model that is looking for humans that are connected, and the number of connections and the distance of the connection matters. In this case, let's talk about addresses. You wouldn't necessarily tell the model that addresses are important, but it could figure out that people who share the same address are connected in some way. So let's say you have a customer that is directly connected to another customer by address. Essentially, they live together. Think of this as having a distance of 1. Now let's say that the second customer we talked about is directly connected to yet another customer by address. Maybe they used to live together, or maybe it's a part-time resident. Let's call that a distance of 2. The parameter would set a score with a direct connection, distance of 1, as 1.0, and an indirect connection, distance of 2, as 0.5. The human user could then tell the model to only create output when the score is 1, or the two customers share the same address. That wouldn't remove the other connections found by the model. It would simply be telling the model, I only want to look at these things right now. The model would also begin creating its own parameters as it finds more and more connections. These are things that humans might not find out. That's how the unsupervised learning model can actually go beyond what you can get with supervised learning. Let's break that down a bit and use a scenario. Assume we're feeding the unsupervised model customer data, names, addresses, sign-ins, transaction history, KYC information, the whole shebang. Now let's meet Sam Dunbar. Sam lives in the city and holds an account with Major Online Shopping and Technology, or MOST for short. The account has direct accesses, as in logins or sign-ins, from Jordan, Jerry, and Avery. Sam, in addition to shipping items to the primary address on the account, has also shipped items belonging to Sydney and Billy. Lastly, Dale has a Most account that has Sam's credit card as a payment instrument, but no other connection. By looking at the account data, the model can see that Sam shares an address with Jordan and Jerry. The model can then connect those three people, as a group, to Sam and each other. Avery does not share an address, but has a recurring login and shares the last name, Dunbar, with Sam. The model does notice that Avery shares an address with Sydney and Billy, to whom Sam has shipped packages. Then there's Dale, who does not have any connection to the other customers, and the only connection to Sam is a shared credit card. The model has found the similarities and connections in the data and created three distinct groups that are all related to Sam, acting as a node for these connections. The first group appears to be a household cluster. They all share the same address, and they all have direct access to the account. The second appears to be Avery's household group, who might be relatives of Sam. Sam appears to allow Avery access to the account and shares a last name. Avery, in turn, shares an address with Sydney and Billy, to whom Avery sends packages. Sam has a connection to all three people, but the most number of connections to Avery, with direct access, a shared last name, and packages going to the house, if not Avery. Both of these groups would be more likely to surface in a model designed to find communities, like a graph-based community detection model. Last, we have an outlier group, where Sam and Dale share a credit card, but no other connections. A model designed to detect outliers, like an isolated random forest, would be more likely to realize the importance of this connection. Could a human have made these connections? Yes, but the unsupervised model can make those connections at a large scale, think millions of customers with thousands of connections each, and find new ones that humans might not detect due to that scale or preconceived bias. Unsupervised learning is fantastic at making connections and detecting outliers, even connections and outliers that humans would never make. It doesn't require label data, which makes it faster to get full performance. It also won't pick up system errors like in supervised learning, even if there's a broken procedure. And if you're trying to find outliers like Dale, there's no better solution. But on the other hand, unsupervised models are less accurate than supervised models for the same reason supervised models are accurate. Because humans don't train them, they come to their own conclusions. That can lead to unexpected results and more false positives, and also finding harmless connections that a human would dismiss immediately, but the unsupervised model can't. That's why unsupervised learning should be part of a solution rather than the entire solution. Paired properly with supervised models trained by experts, unsupervised models can unsurface communities of customers that humans might never think of. And that's it for today's Machine Learning Monday. I hope you've enjoyed this dive into unsupervised learning, and it's helped you have an understanding of one of the more important concepts in machine learning. Next week, we're going to go into the last of the super high-level concepts in supervised machine learning and talk a little bit about semi-supervised learning and reinforcement learning. I hope you've enjoyed the episode. If you have, please like, subscribe, and leave a comment. I've enjoyed making today's video, and good luck, and see you next week. And remember, if you have questions about machine learning, and I suspect you do, Architeuthis has you covered.
Thank you for watching. Please like, subscribe, and leave a comment.